Hello and welcome to Tektronix presentation on TEKEXPRESS PCI Express. I will be using a DPO 72304TX, which is a 23 GHz bandwidth on 4 channels, each channel offering 50 gigasamples per second, and you can operate the scope also on 2-channel mode at 100 gigasamples per second to get further noise reduction. So TEKEXPRESS is a solution from Tektronix, which exists for many different packages. It goes from USB 3, HDMI, LVDS, serial ATA, 100G, 40G, 400G, C-Fi, D-Fi, and more to come. So we are going to use TEKEXPRESS because it's really a lifesaver for engineers that want a methodology for repeatable measurements, implementing the test as per the specifications, and driving the scope to make that measurement in a repeatable way to get consistent and repeatable results. That being said, this oscilloscope with 23 GHz of bandwidth will allow me to characterize from Gen 1 to Gen 3. All the generation are displayed and validated here, 2.5 gig, 5 gig, 8 gig. The two setups for 5 gig at 3.5 dB diamphasis and 6 dB diamphasis, and the 11 presets for the Gen 3. Would like to change that? It's easy to uncheck or check this test here. I will use automated duty control. I know that my duty is right now in 2.5 gigabit per second, and we are using an AFG arbitrary function generator 31252 model connected in USB, and this guy is going to send a pulse of 100 megahertz sine wave on the RX plus of the lane being tested, and that will make the DUT move in the next test pattern in order to process all the tests. Of course, we are implementing the integrality of the required test here, and you can see on the list, and that will be processed by a software coming together with TEKEXPRESS coming from Intel called Signal Test, and I will develop that later on. And you can see that we will be checking the integrity of the signal for most of these settings together. Right now, the configuration is that the DUT is on the board, and I will show you selecting maybe this one and asking a schematic. We are using a similar setup here, but not with that scope because ours is 4-channel. This is a very specific configuration here. But basically, the AFG is connected to the RX lane 0, and the TX lane 0 is connected to the inputs of the oscilloscope. And the DUT is currently a graphic card, which is an add-in card, which is located there. And the bottom board here is called a CBB. It's called a compliance base board, and it's intended to place the DUT in test mode and allow either manual toggling or just powering the board and allowing to be in test mode and using automated toggle right now. So I will close that as I don't need it. And I'm going to run TEKEXPRESS for you on all the tests required. Also, I checked up the auto close of the pop-up during the test, so you will have a brief apparition of the schematic diagram, and then it's going to disappear automatically during the test without me touching a thing. And so you can see that we are already acquired the Gen 1, and we've been toggling the DUT to Gen 2, 3.5 dB diamphasis, saving the waveform, toggling again, acquiring the Gen 2 6 dB diamphasis, doing the auto set of the scope, triggering, acquiring, saving the differential signal as well for the 6 dB diamphasis. And now we are toggling the DUT to 8 gigabit, and switching to the preset P01. TEKEXPRESS is a very convenient way to quickly make the measurements. And as you can see now, yeah, the way we architecture the PCI Express compliance application here is we are acquiring all the required waveforms for further signal integrity analysis. And when we will reach the P10 presets acquisition, then TEKEXPRESS will pass these waveforms to the software I called Signal Test. And Signal Test is a free software provided by Intel, which is the standard tool to assess signal integrity for both PCI Express and USB 3 in order to get an understanding of the pass-fail status and the margin you may get on the different lane of your bus and on the different presets that the bus is supporting. For each signal from Gen 2 to Gen 3, we are acquiring 10 million points at 50 gigasamples in order to contain enough UI to have a meaningful eye diagram and signal validation. So the tool is embedding so the signal test from Intel is embedding the channel the settings as well to make the measurement after channel if it's required by the specification. So the acquisition part is reaching to the end. We are acquiring the last preset, which is P10, and we are starting the analysis using SIG-test. So you will see several instances of SIG-test opening up on the screen, processing and closing in a quick way. And when all of that will be complete, we will call them again to retrieve the results automatically to populate the report that will automatically open at the end of the processing. And we are almost reaching to the end, processing preset 09 and preset 10. And when that will be done, you will see TEKEXPRESS pulling the results inside this own measurement matrix in order to generate the HTML report with the screenshot of the eye diagrams as computed by signal test application. The whole session is saved under X drive and contains all the waveform. So as we can see here, with all the tests from Gen 1, Gen 2, Gen 3, the total execution time is about 6 minutes 44, which is very fast. We can, of course, see that that duties pass on all the important compliance tests here. You can see that you have additional information in tests that have a status of informative because there is no specification on them. And for the remaining thing, you will have the screenshot from SIG test on Gen 1, Gen 2, and Gen 3 eyes. And you can see there are two eyes per generation, because one eye is the full eye with toggling between zeros and one, and the other one is a non-transition eye, meaning that the previous UI transmitted was the same polarity as the one here. So that the specification requires to proceed on the two. So to finalize the presentation, what I would like to say is you can save the test setup here as a demonstration, TEKEXPRESS Auto, and later on you can recall that very simply in the open test setup, or even open recent here, and then you can recall the measurement without reacquiring the waveform by using pre-recorded waveform here, and press run. Thing I'm done for this presentation. I hope you found that useful, and I'm looking forward to meet you for another presentation later on. Have a good day. Thank you.